So we can start. Okay, hello everyone. I'm Oleg, and today we will talk about Bencode and basically about serialization and deserialization in Go. So let's start. Quickly about me, I'm a happy gopher for more than 5 years. I'm open source addicted. I really like open sourcing. And also I'm happy engineer at Go Labs in Warsaw, where I'm happy coding in Go and doing a lot of cool stuff. Also, here is my website, my Twitter, my GitHub, so you can find my contributions, ping me, just ask any questions, and so on. I'm pretty welcome for discussing anything. Okay, so before we start, let's clarify one thing, because there are different terms like encoding, decoding, serializing, deserializing, marshing, and marshing. In this talk, this is almost the same. Basically, there is no difference between encoding and serialization, and maybe somewhere in the world there is difference, but not in this talk. And basically, I think there is no difference at all, just like different notation for the same thing. But anyway, serializer and deserializer. Why do we need them? Because we would like to store data somewhere, somehow. Maybe it's files, maybe it's databases. Maybe we would like to serialize or encode data in some format to make a remote call. Basically, making HTTP request is just sending JSON, which contains some data to the server and receiving it on the client. And the same about gRPC, where data is encoded in protobuf. Basically, it can be encoded in any encoding, but by default, it's protobuf, and so on. Yeah. So our encoder and decoder should be fast, because we do not want to spend our CPU cycles on processing data, and we would like to make it as fast as possible. Because why we should wait, I don't know, maybe like 10 minutes before you can write one row inside Postgres. It's nonsense. You don't want to wait on such a simple operation. And also it should be memory conservative. So if a serialization is fast, that's cool. But if it's consuming, I don't know, maybe like gigabyte or maybe even 100 megabytes, it's just nonsense, because you're just spending your memory limits. Memory is not infinite, and you would like to consume as much as possible. And also, memory consumption is heavily related to garbage collection. So because we are living in the world, we have runtime, we have a garbage collector, and we do not want to make it runtime's life harder. Okay. Clicks. So super. Serializer in one picture is basically we have some data. We have an object in our heap in Go, and just writing it in some format. So here it's JSON, but it can be anything else. And as you might guess, the serializer is a reverse process. We just need to pick up JSON in this example and map it to some structure, and basically write user ID from the left to user ID on the right. And yeah, simple as it can be. Sorry. Okay, I'm just checking chat. Anyway, classification of encoders. There can be schema driven. So basically, before processing your data, you need to specify its schema. So basically how it looks like, what are the fields, what is the type of the fields, is it repeatable, is it nullable? So you can skip something, maybe something cannot be used, and so on. And just a few examples of them, maybe the most popular examples, but as you know, its list is almost infinite. Another type, it's binary. It can be GOP, which is Golang. I'm not sure how it's called, but anyway, it's GOP. It's inside stdlib, so we can use it from stdlib. But it's not so popular because it has some limitations. It's not so fast, but anyway, it exists. Another option is MSG pack and BASON, which is basically binary JSON, which is heavily used in MongoDB, I think, and maybe in some other applications. And the next type is text. So basically some simple textual representation of your data. It is JSON, XML, YAML, XML, and like ton of them. Probably text. So I will cover it later. But anyway, this classification is not written in stone. Basically, it's one of the representation how it can be viewed by user or by developer. So you can add your another types or groups for encoders and decoders. It's up to you. So let's talk about schema driven. What are the pluses of using them? They are binary because you have schema and you do not need to read your data as a human. So you are just offloading your task to the machine, which can process binary data much faster. And because it's binary, it's more compact because integer is just like 8 bytes, and you do not need to write, 10 digits just to understand what is inside. And also we can use code generation because we know how does the schema looks like, and we can just generate some code which will process our data via schema. And because it can be it can be faster because code generation basically optimizes our process. What's not so good? We need to define schema, so we can't just create some arbitrary data and say, okay, just encode. So schema must be well defined, and sometimes it might be a limitation, but in most cases not. Maybe it's hard when you're prototyping something or you're receiving some data from user. You cannot create schema for it. But almost anything, almost in every example where you have communication between client and server or between services, it can be done via schema because you are just a developer who develops this connection. And also there might be problem with tooling because code generation must be made something via some tool, but it's not so big problem. And also there's pluses and minuses because such data can be used between different languages because everything is offloaded to the code generation. And if you have code generation in your language like Python, Ruby, maybe Haskell, everything will be fine. But if not, you need to create it from the scratch, and this might be a problem. But in most cases, almost all languages are supported for protobuf, flat buffers, cup and proto, and Avro too. Okay, so about binary. Why is that good? They have some kind of schema because they are mapping your data, which is written in code, to some binary output, which is cool, but it's not so flexible as the previous example with a well-defined schema, because suppose you can reorder your fields in your structure and basically have a new structure, and you need to keep a version of your data just to understand how to map it in the serializer. And also basically fast because you're just writing your data from memory to the disk. That's pretty cool. Which is not cool because it's not for humans. It's hard to understand what is inside. And basically, there is no tooling for this in most cases. So you need just deserialize to understand what is inside. And also cross-language compatibility might be a problem because it's not so easy to, let's say, save an object from Python heap and open it inside Go heap, because layout of this data can be pretty different, so you can just receive a garbage, which is pretty uncool. And last type, it's text. It's super easy, so I think everyone can read JSON. It's not so hard. XML, maybe it's not so easy, but anyway, well, I have written XML 2 times. That's cool. Anyway, so it's easy to read. It's also easy to integrate because it's well supported formats in our world, and which is not so cool because they need to be parsed, and parsing can be pretty complex because suppose you have 2 JSONs. One is some JSON, and another one is the same JSON but with additional spaces. And basically they are the same, but they can be different. Like first one can be 10 kilobytes and another one can be 10 gigabytes. But basically just a lot of spaces. And this is uncool, but still it's possible to create such JSONs. And also they're not so compact because they should be written by humans, and we cannot compact some data inside. And also we're losing data because we cannot distinguish is this int or is this float unless you have 0 dot something inside this number. So when you are deserializing your data, you're not sure have you encoded integer or float, and this also can be a problem. So let's talk about Bencode. Bencode is encoding, which is used mostly in peer-to-peer file system, file sharing. in the torrent. Basically, your torrent file, if you have downloaded somehow, one of them, they're encoded in Bencode. And it's horribly unpopular because it is used only in torrents. I haven't seen any examples where they use outside. And GitHub just confirms this assumption. Basically, it's not an assumption, it's true. But anyway, it's pretty interesting format. And that's why I have decided to implement it. I have started this, I think, a year and a half ago, maybe 2 years ago. I had an idea for a project, but somehow I started writing Bencode encoder and just forget what I wanted to create, and just continued it in this January. But anyway, I would like to share my story. So first thing, it's pretty simple. So encoding integer is just wrapping your integer with I and E at the beginning and the end, and that's all. String is almost the same. You need to prevent length of your string, just add dots and write your string. So simple as it can be. Creating list is always the same. You just need to prevent with L and E on the end. And basically inside list, there can be any data. So there's no limits. You can create some of your trees or any other context data. And almost the same about maps. Basically, they're called dictionaries inside the Bencode standard specification. But I will call them map here because it's more familiar for Gophers. And there's only one thing, keys of this map should be sorted. So if we have, suppose we have a map with foo and bar, bar will be always first because it's lexicographically less than foo. And also map is just preparing D for dictionary and E on the end as end. And yeah, so let's talk about API. Maybe you have read different packages inside encoding directory in stdlib, where we have JSON, base364, XML, and other formats. And most of these packages have API which looks like this one on the slide. We are creating encoder. We are waiting for some writer from the user where we would like to write our response, our result, and also encoding, which receives some empty interface because we are happy to encode any arbitrary data, which user will pass for us. And almost the same, but reverse story for decoder. We just receiving reader from which we would like to receive some raw data encoded in Bencode, and just to write response to the decoder to the empty interface because it's arbitrary type from our user. Okay, so basically it looks good because it's familiar for Gophers. It's awesome, and yeah, it's also format for different. It's API for different formats too. As you might know, YAML is not in stdlib, but still it has the same API because why we should bother someone? I have a question. Is there anyone who has questions? Okay, so chat is empty. I will continue. But okay, is it enough? Is it optimal? And can we do better? Because API is pretty open question. There is no best answer. I think there's always some process or iteration before creating something better. Okay, let's make it enough. I mean, enough as an API. As you might know, I think you are also using a function from JSON package in stdlib, which is called Marshall. Basic idea is you are just passing some type, some variable, some data, and receiving a JSON representation, or maybe error if something is not so good. And that's cool because it simplifies user life, not to create new encoder, passing some writer, which in most cases is just bytes buffer or I don't know, maybe response, and we can encode function on this encoder method. And the same for unmarshal. So there's no need to create new decoder, pass the code, you just say unmarshal me this byte slice to this variable, and that's fine. So small simplification, but really reduces noise in your code. Okay, so let's make it optimal, because our current API with Marshall, or it's not good as it can be, because always when we're passing some data to the Marshall, we are creating new byte slice in which we decoding our data, and that's not cool. But it's not a big problem. It might be okay. But if you'd like to make it more optimal, you can pass already created byte slice, which can be pulled, which can be created before, or maybe you are expecting some size of your response of your Marshall data. So you can create it before and say, and pass it as a first parameter to Marshall2 function, which writes data to DST, which is named from destination. So basically it's destination where we would like to write our data. And also there is no need basically of this parameter. I'm not sure, maybe I have deleted it from our repository, but anyway, I will check. It's not a big problem. Okay. And also the phone interfaces, because users would like to create their marshalling by hand, because they know how data is represented. So if you know your structure contains 10 integers, maybe you do not need to pass it to the marshaller or to the encoder. You just can return a byte slice which contains serialized data. It's not so useful, but in some high-performance systems, it's pretty cool thing, because you're giving more ability to your users of your API. I have seen such examples in JSON. Well, I mean, with JSON marshalling, there is also a lib called EasyJSON, which basically helps you to generates code for serializing your data. So your JSON serialization is pretty fast, because you have already code that will exactly generate JSON exactly for your data. So you don't need to parse it somehow or just see how your structure looks like. I'm not suggesting to use it because it's pretty complicated, and be sure you're not using it just because someone said it's on Meetup. It's not cool. And the same about another Marshall interface, where we know that user can decode data on their own, and maybe for someone it's needed. So why not? And basically, it also makes our APIs symmetrical, because encoder and decoder has the same capabilities, which is also cool. And okay, so let's make it even better. Sorry, strange. Okay, I have downloaded old version of my slides. Anyway, make it better. We have Marshall Bencode method in our Marshall interface, but there is still a problem. When user invokes or implements Marshall interface, every time users allocates a byte slice where he or she writes serialized data, which is not so bad, but still in some high performance systems, or where we would like to reduce our memory consumption, we'd like to reduce our memory usage or memory allocations. And that's why we can create another method inside our interface, which let's call it Marshall Encode 2. Sorry, where we are passing writer to our user, and user just writes serialized data inside our encoder. And it's also cool because we're not allocating something new, and the user has ability just to write response exactly to the result exactly to the resulting buffer. And this, I think, runtime will be also happy because there's no need to track more data or pointers. Okay, so one thing, let's talk about sorted case in dictionary. I have found this optimization because I was bored. I was looking like, okay, I would like to make this even faster. So what I can add or what I can imagine. And I was thinking about that most of the structures contains not so many keys, like, I don't know, few tens, thousands, I'm not sure, but maybe few. And so why not to optimize this case? Suppose we would like to optimize keys where we have less than 20 keys inside our dictionary or inside our map. And basically we can sort it faster because they should be sorted by the specification. And there is a thing, sort strings is just a wrapper over string slice. I think in this January, Dave Cheney has posted a good blog post about problems with sort function because it allocates our slice on the heap. Basically, it escapes to the heap. It's not a big problem, but still it's not so optimal as it can be. So let's solve these problems. However, it's not a big problem. And let's quickly talk about bounds checks. As you know, Go is a memory-safe language, so you cannot access, I don't know, element which do not exist inside slice. So we have slice of 5 elements. You cannot access 7th element or 10th or -1 element. You will have a panic, which is cool because you cannot access some arbitrary data, arbitrary memory. You cannot change it. You cannot read it. So you have safety. Just you cannot break something. You just will have a panic which you need to somehow process. Basically, you can access some arbitrary data with unsafe package, but that's why it's called unsafe package, and not everyone allows you to use it. Suppose I think AWS Lambda and Google Cloud App Engine don't give such abilities, so you cannot use unsafe at all. So basically, process inside during compilation, it's called adding bounds checks, adding checks that will check your bounds during runtime. And those bounds are not, so they have some impact on your code. And if you have a hot code, which runs, makes a lot of computations or a lot of iterations, you would like to remove these checks because in most cases they are not needed. Because you are so smart, you can understand what is your data and help compiler to remove them. And this is called bounds check elimination. So basically, how it's related to our fast and small sort. Let's look at simple implementation of insertion sort. So we have an if, we have a for over all elements, and another for which goes over these elements. It's n squared complexity, which is not so good, but because we have only 20 elements in our example, in most cases, it will outperform almost every sorting, or like quick sort, merge sort, heap sort, and something else. And it will use Go Perf tooling, which can help us to find bound checks. I have presented this tool a few years ago on Golang course meetup, and also you can find it in my profile on GitHub. It's created by me and also by my friend Iskander, which I think is here in chat. He is an original author and just like copying his work. Anyway, if we use this tool, it will help us to find places where we have bound checks. And so we know where we can eliminate them, because here compiler is not so smart and it cannot understand that our J index always is presented between 0 and ends of this slice. So it's not possible to receive sub J, which will be outside of our slice. And just rewriting loop inside, like extracting this expression from the loop, from the second loop to the if, will help our compiler to understand it. And that's why running go-perf bounds check dot basically on this directory will give us empty output because there's no bounds check at all. The performance gain, it's not so big, but if you run it like, I don't know, by 100 billions times, you will receive good performance gain. But it's not so important, but still it's cool. Let's talk about fuzzing. It's randomized testing for Go. There is one repo created by Dmitry Vyukov. It found like tons of bugs in different applications because you just like giving to your code random input, random byte slice, which arbitrary, but still it's not so arbitrary because it looks on your code coverage and tries to find another pattern of this byte slice to find these places where your code can panic, or you might have seek faults or different unpleasant things. And it's super helpful for deserializers because you can find different cases where your deserializer is not so smart, and you can create some logical bugs which are not so easy to find, but automatic tool will find it. So I really suggest to use it if you're creating something which parses, or I don't know. So basically everything which is related to parsing should be fuzzed via this tool. And also I'm not suggesting to use it on CI because it's not so cool to spend like 10 minutes on your build and will give nothing. Basically, better to run it from time to time on your machine, or maybe on another machine in cloud, and see have you find something or not. Okay, and yeah, everything looks like one file. It's also inside the repo. We just need to create fuzz function, which is even some byte slice, and just to use this byte slice in unmarshalling. And return 0 if something is not so fine, and 1 if everything is good. In most cases, your code will panic because you have some problems with boundaries on this byte slice, and you will receive a file which contains this input. So 20 lines, but like tons of bugs just covered by automatic tool. That's cool. And let's talk about benchmarks. It's really hard to create a good benchmark. There is no serial build. It's strange point of view because everything depends on your case. Maybe in your case, JSON will work faster because you have some arbitrary data, or it can be easily compressed. And there's no need to use protobuf on this because protobuf usage will just spend time on something which you don't need. Also, there is a cool thing to see not how much time takes your serialization or deserialization, but also how much memory you are using in terms of how much memory allocations and how much raw memory is used, like in megabytes or kilobytes, depending on your case. And also, it's good to test not on or benchmark not just on one type of input, but on different types, which can give more insights about how your serializers works on different things. And yes, I have mentioned before, not just operations per second, but also locations and how many bytes. So let's look at the examples of encoding. First one is just simple marshalling, and another example is marshalling, which decodes in some prepared before byte slice. As you can see, the difference is quite visible. We have 0 allocations because we already created something where we have created byte slice where we will write our output. So there is no to allocate something new. And also, that's because we're not allocating additional or temporary data, we can process this faster. There is also Marshall Bencode packages on a GitHub, which shows pretty good results. But I was looking to creating something on my own, and just not only for practice, but also for writing something more go away without unsafe packages, just because I would like to squeeze some additional nanoseconds. And also marshalling in my repository works without unsafe. I think so, because if you're writing something carefully, you can achieve good results with Go. And it's also a good feature. Decoding it's not so fast because we are receiving some like chunk of memory, chunk of bytes, and we'd like to serialize to some data. And we really need to create this data because we'd like to return to the user. That's why we have additional allocations. And here almost the same story. We are allocating something because we need to allocate. And also processing speed is slightly worse, but still pretty acceptable. All these benchmarks are available in another repo, which also available in these slides. Okay, one mem instead of thousands words. Writing serializer is pretty cool because you have some data in memory, and just with few, I don't know, hours, maybe days, maybe weeks of thinking, you can make you can make it pretty optimal without additional allocations, without spend nanoseconds or something that you do not need, and that's cool. And the serializer, it's not so fun to write because it's kind of boring. It's not so obvious. Sometimes you need to touch reflect or other interfaces. I mean, empty interfaces, but someone's need to make it anyway. And okay, where is the code? Code is located under organization on GitHub, so you can use it. It's 0.11 currently. I think I will add more features shortly. Maybe not shortly. Anyway, I would like to add some features. Benchmarks are available in another repo, so there's no additional dependencies just for benchmarks. I think which is quite useful because users of original repository will not pull like an additional 10 repositories just for benchmarks. That's nonsense. And I also suggest to look at another benchmark repository, which contains different serialization benchmarks in Go. Also see a repository where I'm trying to create production-ready packages, mostly written by me or by my friends, because I need to run something in production. Not also me, but also my friends. And so maybe you'll find something useful for you. And also perf that I have mentioned before, so feel free to use it. I will try to add a few features from benchmarking in some time in the future. And also I really suggest to see this presentation by Klaus Post from GoSystemConf from December. It's really great introduction regarding serialization data in Go, and not also in Go. Also, thank you for my friend Bogdan, who helped me optimize repository a bit, and Roman for creating these beautiful slides, and also you, my dear gophers, for coming today. And that's all.